Good afternoon and welcome. TJ Crow will be presenting teaching statistics with Desmos, and we can go ahead and hand it off to him here in just a moment. If you have any questions during the session at all, please feel free to enter those in the chat section at the bottom of the Zoom room screen, and we'll address those at the end of the talk. So TJ, you can take it away. I think you are muted still.
Right, you're so right, I was muted. Just as well, I really wasn't saying anything important. I'm trying to share my screen now. Let's see what happened here. I don't think my screen is getting shared.
I can see your screen. Teaching statistics with Desmos at the top left corner.
All right. And still struggling with my Zoom. Hold on, please, everybody. Quite very good. So you see this big web page I made for this talk. The link for this web page is in the chat. And you're welcome to open it up on your system as you listen to me go on about all this stuff. The overall, here it is, it's quite full of stuff. The overall theme, if you will, or story behind this presentation is that I'm retiring in December, and I've been teaching at Blue Ridge Community College for 18 years, teaching stats for a bunch of that. And over the past 2 years, I think, I've been using a lot of Desmos and put a lot of work, particularly into some of these statistics Desmos graphs. And I would just like to pass them on and present them and pass them on to you all in hopes that you'd find them useful. And maybe even get somebody interested in further development of this suite of Desmos graphs. That's if you enjoy programming, and I do enjoy programming. In fact, I worked as a programmer back in the 90s, and I found that Desmos programming environment, if you will, was quite nice. Okay, so on this webpage, we have kind of an outline of the talk, and then we get into a bunch of miscellaneous stuff down here in this column. The second column introduces the Desmos apps that I want to show you. And each of these pictures is actually a link to the app itself. Things will go along, and what we'll do is we'll just go through these apps and get as far as we can get. I imagine there's a lot more material on here than we can cover, but hopefully it could serve as a reference or an object of curiosity. You could poke around and see if there's anything you could use for your class, not just stats, but I also stuck in some Desmos stuff that I did in other classes as well. Very good, friends. Let's begin with the Desmos Dataview. Desmos Dataview uses all of the typical visualizations taught in Math 245. I noticed that I still have Math 245 here. I realize now, after a recent math department meeting at Blue Ridge Community College, that we're going to be also offering MTH 155, I believe is the correct number. That is for the what we're calling baby stats. I forget the title of it, but it's a little bit more conceptual. And the fact is, these Desmos visualizations could be even more handy in the MTH 2 or 155. Correct me if I'm wrong on that. I think that's right. Can I have an amen from somebody out there about 155? Is that the right number?
That's right.
Yes, yes, it is. It is.
Thank you so much. We're going to put that up there right now. There it is. Oops.
The technical title is statistical reasoning.
Thank you very much. I was going to say statistical concepts, but I knew that wasn't quite right. All right, so and it includes, you know, all your favorites: histograms, box plots, z-squares. Let's take a look at one. Oh, I know. Here's something. You can even Google it. This I'm kind of proud of. I'm going to Google Desmos Dataview, which is my own brand name that I made up for this. And there it is. Desmos Dataview on the net. Here, let's take it from here on our webpage. And you're welcome to open this up with me. And you should see this same display where you see the box plot histogram and the mean and standard deviation right there under the x-axis. Go over here and click on the dot plot with me, and you'll see all the individual pieces of data arranged in order inside of each histogram bar. That becomes very useful. Z-scores, if you click on that, you'll see these blue points on the x-axis showing you where the z-scores are. And just as an added nicety, we have a normal curve overlay taken from those z-scores. And this is designed so that, like you say, like it says here, to display your own data, open each folder and turn and follow the directions. Each folder, for example, here, the data folder has directions inside of it. And one nice thing about this is that you can store multiple data sets down here, describing them with subscripts, and then actually display the variable X. So if you want to change data sets, you go down here and copy this and paste it here, and boom, you've changed the data set. Now, when you change a data set, it changes the view. And if you follow the directions, you'll see the next thing you're supposed to do is press this magnifying glass, which gives Desmos a chance to give you a decent zoom to start with. After this, in this folder, you can fool around with the width. Here in this folder, you can redo the title. And yeah, this one isn't redone yet, but they're all going to get redone to make these movable. Anyway, at this point, to move this thing around, you got to open up the dot, move the title around. What else? The dot plot doesn't have any settings to make. You just turn it on or off. Box plot here, along with the quartiles, you can turn them on and off separately. You can change the position of the box plot and the height of the box plot. Turning on and off the quartiles, there's no setting there. Mean and standard deviation, you can turn on and off as well as set its height. And yeah, here's one that you can drag. One of the to-do things is to get back into all these apps and make sure that all the titles are draggable. Z-score is nothing to set, and here for the normal overlay, as I call it, you can set the height. All right, so there you go. There is the Desmos Dataview. And there's any questions at this point? Were you able to manipulate it on your own there? I'll take that as a yes. All right, good. Yeah, I hope you're playing around with this stuff as I'm talking. Histogram assignment. There's a couple assignments that we developed to go along with the Desmos Dataview. And this first one introduces the Desmos Dataview. Students make a Desmos Dataview from the data in a Google Sheet. And I didn't provide all those links, but I gave you links to the videos that I developed for the students. Here is a introduction, kind of like what I just gave you about the Desmos Dataview. And then this actually tells them example of how to do the assignment. where they take a data set off of a Google sheet, copy the data, put it into the Desmos Dataview. There it is. And then fool around with the settings until they end up with a nice looking graph. So there's an assignment that just says do the histogram, basically taking care of the first 3 folders here in the Desmos Dataview. Then we have a data report assignment. Here the students create Desmos Dataviews of the survey project data and answer custom MyLab questions based on the data views. All right, so this survey project data, it's explained a bit over here under this topic, student survey project. This is the class project for the semester. Excuse me. And what they'll do is they'll use this, well, let's explain a little bit about this survey project, I guess, at this time. First of all, they fill out this survey. And here's a bunch of yes or no questions that can be used to, for population proportion studies. And here's how much questions that can be used for figuring out the population mean issues. All right, so what's your height, what's your age, that so forth. There's the survey. And then we give the students this sheet with the compiled results from the survey. And because we had 4 pretty full sections of calc, we got a large data set, which is pretty nice. 95 students responded here. And, with a large data set, you can actually say something meaningful about the population. All, of course, with the assumption that this class data set is a representative, simple random sample of the student body, which of course isn't true, but we just pretend it is. Or we use that assumption just to demonstrate things. So anyway, there's the class. Oh, I want to show you this thing too, because this is way cool. When I was making up these custom questions for one of the assignments in the project, the final assignment, what I did in this Excel file was I took all this data, and at the bottom of each column, I ran either, I estimated population proportions and have this way to do hypothesis tests for each column of this categorical data, and over here for the numerical data, similar thing. Each of these tables calculates an interval estimate and does hypothesis tests for the student data. And then the answer, this allowed me to, get the answers to the questions that I would use for the custom questions. All right, so there's some Excel programming of simple stat functions, hypothesis tests, and interval estimates that you might find handy, all pre-programmed by me for you. That is now to introduce the student survey project. Let's go back and talk about this assignment called the data report assignment that further exercises our students in this Desmos Dataview. They're going to create data views based on the student survey data and then answer custom MyLab questions. Let me show you some of these custom MyLab questions. And we'll hope this window is still active and working. There we go. Yeah, here's an example. So the MyLab question says, create a Desmos data view of the heights of the students. Let me show you down here I have this link, data views of all survey data, just jumps down here. Heights, here's the height. So what they would do is they would create this Desmos Dataview on their own. And then they would answer these questions. So here's one. The data is skewed to the right. Is it skewed to the left? No, it's approximately normally distributed. Half the class has heights between 63 and 71. You got to go up here to the box plot and locate the 63. Half the class between 60, well, they got to be talking about the middle portion here. So the correct answer is 71. There are 1 unusually tall students. How do you find out if somebody's unusually tall? You turn on the z-scores. Boom. But even that's not enough, because what you want to do next is turn on the dot plot, and you can actually count and see that one person who is unusually tall with a z-score above +2. There are 0 unusually short students, and that is true because you can see there's nothing below a z-score of -2. Again, if you'd like that normal overlay, you can lay that on there as well. And then the tallest student, the shortest student, that comes off the box plot. Z-score, they have to calculate themselves. There are 0 outliers. So like that. Let's take a look at this next one as well, and then we'll move on from this. Data set 4, miles from campus. See if you can find this with me, data set 4 here. And we can open this guy up. And this would be like the graph that they would create in the assignment, and then answer the questions from the graph. Here's which average should be used to represent a typical value. Obviously, the different thing here is that it's not normally distributed as way skewed to the left with a bunch of outliers. The correct answer here is use the median, because the data set has large outliers, right? 75% of the class lives 22 miles or less away. That comes off the box plot. Here's the one I wanted. Question 5. There are 5 students who live unusually far from campus. Here's where you need both the z-score and the dot plot to count 1, 2, 3, 4, 5 students who live unusually far away from campus. So it's like that. That's what this data report assignment is like. And I posted up here the videos that explained how to do the assignment to the students. Here's this first video is how do you set up your own data view. And the second video is going through a bunch of sample, well, the remaining videos going through example questions. Okay, so let's pause for a second. So far, we've just talked about this Desmos Dataview. What time is it? 20 after. And are there any questions? All right, good. We've pointed out to you the data views of all the survey data. I've done this for 2 years now, where I had 4 big sections of stats. This, of course, fall 2020 was the pandemic, the first pandemic fall. And you can do fun things with this if you'd like. You can compare from year to year what the age of the students are. Here, this year we went from a low of 17 to a high of 34. So here you can see the range from last year, so forth. The exciting thing in doing this data report assignment, I tried to convey the excitement of actually discovering what your data set is all about by making one of these graphs. I don't think we have the time to get into the process of how to make these graphs. It's on the videos. But what you do is, you just enter the data in here, and then suddenly you have to start massaging it, and the data set takes shape and begins to have meaning for the students. And I don't know, I just think it's kind of exciting to investigate the data that's based on your fellow students. Here's a special thing about grades. I'll have to be a little bit embarrassed about contributing to grade inflation, but I'm not used to teaching online. So just a couple of things. If you want to use the data, Desmos Dataviews for your class grades, then you need to have a special width setting of 10 plus a smidge in order to get the bars to work right. But I find these handy. I mean, here's like a little time sequence here. After test 1, after test 2, you can see how the grades are getting a little bit more spread out. And of course, you can actually see all your individual students. And you can see who's unusually, doing unusually poorly and stuff like that. Here's I think a full-time sequence we can get from last year. To give these a chance to load. And then we'll see how the class did over time. Here's where they started out after the first test, after the second test, third test. You see what's happening, of course. So that's kind of fun. You can create these time sequences. And then the handy thing is that you can store all the data in one file and then just create the different graphs, changing the data sets as you go along, and then saving the link. So you don't need to have a bunch of different files, but from this one Desmos file, you can make all the different graphs for all the different data sets that live in your Desmos Dataview. I think that's it for Desmos Dataviews. Very proud of that catchy name. I hope you find them useful. And we'll just take another pause. I'm not going to make you stand up and stretch. But in your imaginations, if you would, stand up and stretch right now. Imagine what that would feel like. All right, so now back to my outline. I'm going to go on and talk about all these Desmos calculators that I used to teach with, mostly. And it starts with maybe calculators that you may have seen versions of Desmos calculators that do this much. They calculate normal probabilities and calculate the cutoffs for the inverse norm. So let's just take a peek at these two, see how they work. Here's the instructions. You set the mean and standard deviation, right? And then choose one of the three probability expressions, read the probabilities. So you can look at the probability to the left of the left, and you can look at the probability of the right, left to the right. You can also look at the probability in between those two. Of course, you only do them one at a time. All right, so that's pretty straightforward. You read the probability down here. For inverse norm, of course, you have to specify the proportion under the curve, and then you read the cutoff there. And again, you can do it either right tail, left tail, or center. Now, I hope, my friends, that you are doing this with me, because these are fun to play with. Any questions on those guys? Those are kind of typical calculators that you'll see. Although, wearing my programming hat, I tried to make them as user intuitive as possible. All right, let's move on and talk about, this is just a quickie here, t-distribution demo. If you ever find yourself trying to explain the difference between a t-distribution and a normal distribution, you can use this little guy. Shows you how the t-distribution's shape gets a little unnormal until, you get above 30 or 40. So like it says, manipulate the n slider to see how t-distribution differs from the normal distribution. All right, the rest of this column is the data views of student survey data. Let's go over here now to this last column, sampling distributions. This, I think, is probably the most novel thing that I'm introducing are these sampling distribution applications. I use them to teach, excuse me, to teach the idea behind sampling distributions. I talk about it down here when I talk about the assignment that goes with these, intended to give students the connection between probability theory and statistical inference by calculating a p-value using a sampling distribution. And that's what these guys do. They calculate a p-value. And in the lessons, we talk a lot about how underneath this curve, you are to think about all possible samples that you could possibly collect. And then you make an assumption about what's in the population. For example, here, whatever it is we're talking about, there's 50% in the population. Let's say the percentage of women, right? And then we talk about how likely is it that you would pick a sample that would have only 42 women out of 100. Well, that likelihood would come right off of this graph. It's this portion of all possible samples that have a p-hat less than 0.42. And we have a similar one, of course, for sample means as well. Let me talk about the sampling distribution assignment. I put the whole thing up here on the website. It all started with this thing. This was like 3 or 4, maybe 5 years ago. Anyway, some years ago, when I did it all before we had the Desmos stuff. And I lecture off this this handout talking about inferential statistics, how a sample stat needs to be considered as a random variable, so you can talk about its probability distribution, which we call the sampling distribution. And we give them this little piece of wisdom about the low p-value, and we explain it up here about how p-values can give you a way to say something about the whole population in the sense of, disproving a null assumption. So, we're kind of getting ahead of the game as far as hypothesis tests go, but they don't know that yet. So we give them this, we give them a little chart. Yeah, we don't, in this lesson, have a cutoff like you do with the hypothesis test. We have a range of evidentiary strength that we use. And then we have this chart, and then we have these examples where we show them how to use the sampling distributions to calculate a p-value. And it's a very easy, 3-step process, very easy, of course, with this Desmos app. And there's 4 examples in this handout and a bunch of exercises, all of which got transformed or transferred, if you will, into my lab. So let me show you what that looks like. This is sampling distributions now. Yeah, here we go. And the layout of this, of these custom questions follows the layout of how I want them to do these problems. And in the end, they make a conclusion like this one, for example. Yes, I have strong evidence that the percentage of BRCC students who live at home is more than 42%. That again gives the students a feel of how to make the logical jump from collecting a simple random sample, combining that with probability theory, and coming up with statistical inference using a p-value. So I think I'll recommend you to looking at all those videos if you wish to see how that lesson goes. In the first 4 videos, we talk about the lecture. In these 4 videos, we go over the 4 example problems. The 4 example custom question problems. Speaking of custom questions, if you are interested in copying these questions, well, as far as I understand it, it's not an easy matter. I still haven't gotten to a point where they're actually ready yet. I don't think, I don't know, somebody would have to try this and let me know. I put it under here under miscellaneous custom questions. In other words, I ran out of time working with these people to make sure this really works, but apparently because I created these custom questions in a direct integration with Canvas, Pearson, using Triola text direct integration with Canvas. The only way you can copy these custom questions is if you also are teaching a course with direct integration with Canvas. And all that's explained here. And I would love it if somebody would try doing this and see if it works. All right, so that's if you're interested in taking a peek at these custom questions. By the way, writing custom questions like this, it takes some time, but it's not too bad once you get the hang of it. All right, let's move on. What are we doing here? It's 11:30. Okay. So that was all about sampling distributions. And then just 2 more groups that I want to show you. So let's take another little pause for a stretch. Or virtual stretch, as you wish. My version of stretching is to have a little more coffee. So as you know, towards the end of the stats course, we teach our students how to do hypothesis testing and compute confidence intervals, and that's what this suite of Desmos apps helps with. Let's take a look at this very first one for hypothesis testing on a population proportion. Here you set the number in the null claim, the null hypothesis. Here you put in the sample stats. And then here you choose your alternate hypothesis. And then you read the p-value down there. And that's all there is to it. We have 2 versions for the testing a claim about a population mean that uses sample stats, and one that uses data, for which the sample stats are then calculated. Data gets put in here. And that's pretty straightforward. Again, I went out on the net and looked and looked and looked at different ways that people did this. And I gotta say, I spent a lot of time on making this as simple and clear as possible. I don't think you'll find any of these kind of apps out there that are any better in that regard. If you don't mind me tooting my own horn. It's just so weird giving a lecture like this without without getting any feedback back. Hope you're all having a good time out there. Anyway, so that's the hypothesis testing. And here I'll make the comment too that these apps are just pretty much just a reworking of the sampling distributions where we also calculated a p-value. Let's show you the difference here. And again, I hope you're playing with all these at home while we're talking about them. Here's the distribution of sample proportions. Here is the hypothesis test for population proportion. And really all I did was I took these different choices here and I turned them into alternate hypotheses. That's basically the difference. Very good. All right. That was that comment here. And we're ready to move on and take a look at the confidence intervals. For the confidence intervals, let's just start looking at the proportion one here. I also showed the sampling distribution curve, even though when you calculate the confidence interval, it's just going to show up as a couple dots underneath. And the curve, in a sense, is a little misleading. I mean, in your interval estimate, you're going to have your p hat right in the middle. And well, this here, let's do the walled confidence interval is what we normally teach. It has the same margin of error on each side. There's also a different kind called the Wilson score, which we also provide. Let's just stick to the walled for now. But what I found handy with this was for teaching purposes. To show a student where the interval comes from, you can go down here and shift this thing left to right and show how the high side of the interval comes from saying, well, you know, with our sample right here at 275, the population could be as high as 303, whatever the number is, 302, could be as high as this and still have our sample be reasonably possible. So that gives us the high side of our interval. The low side of our interval comes from saying, well, you know, the population could be as low as 247 and still our sample would be reasonably possible. So again, we're bringing in this whole idea of the sampling distribution curve representing portions, you know, representing all possible samples. So I thought that was a nifty trick that you're able to show students where the interval estimate comes from in terms of looking at the distribution curve. Okay. And if you look down here, you'll see all the fancy programming that I got into, and hopefully if anybody wants to take this stuff over, you too can enjoy programming these things. Now, showing you that nifty trick reminds me there was a similar trick with the hypothesis test. We'll back up and do that in a second. Let's see about the rest of these comments. How sampling distribution shows where the interval comes from. How confidence level affects interval size. You all know that one, right? So let's take a look at this confidence level slider. As the confidence level decreases, the size of the interval decreases. And you can talk about that. You can even talk about that in terms of this shifting, right? Now we're with the decreased amount of confidence. Looks like this. And then similarly, you can go the other way and show them how that interval increases. All right, so there it is. Proportion has both regular walled interval and the Wilson score interval. I'll let you read up on that. To do the Wilson scores are, oh, that's already mentioned somewhere else. That little item that I'm just getting rid of now is mentioned in the miscellaneous section under future development. I want to go back now to one of these guys here. Okay. Now, when I'm talking to my students about how this sample provides evidence, let's give it a p-value of, say, 0.2, 0.1, 0.16. Sorry. Ah, where'd it go? Sorry, friends. Fumbling here a little bit. Okay, let's say our sample came in at 14.2 average. And it's ridiculously high. It's almost impossible that this sample could have happened under the assumption that the population mean is 12. In order to explain to the students how this infers that the population proportion must be bigger than 12, we have this secret slider down here for teaching purposes only that will actually move this curve a little bit. I see I need to, excuse me, friends, I have to make a note here about how I've got to set all sliders. 2 minus 2, 2. Okay. This should be set to 2 here. All right. What was I saying? I was saying that, there we go. You can slide this curve over and say, look, I'm going to get it re-zeroed and start from the top. Boom. Come on, 0. I'm not supposed to. How about I do this? 0. That'll do it. All right. So I say, look, this sample has a ridiculously high sample mean, considering the sample size and so forth, if we assume the population is at a mean of 12. That means the population mean has to be bigger. It has to be a situation that's more like this, where maybe the population mean here is more like 13, because that makes the sample that we actually got more likely, since it increases this area. So you can use this little trick to impress how, you know, a really extreme sample makes this inference that about the mean in the population, how it has to be closer to the sample stat. All right, so that's a little teaching feature that appears in these guys, in the hypothesis testing. And then the other teaching feature in the confidence intervals was showing where the interval comes from. Did we cover it all? Yes, we did, except for some of the miscellaneous stuff. How about we take a quick look through that and open it up for questions? We did that. We did that. Assignments. Oh yeah, this is the assignments that I used in the course that use these applications. Miscellaneous custom questions. We talked about that. Here's, oh, this is something older that I did once and still use. Back when I used to teach this using the TI-83 calculator, I created this Excel file that actually simulates all the TI-83 calculator functions that we used. So for example, here's one var stats. This helps you make a histogram. This is inverse norm and normal CDF, one prop Z, and you know, all your favorite calculator functions. And so I still find this handy to this day, even though I don't teach it anymore using the calculator. It's especially handy to have these little guys to work with if you want to figure out answers to problems. Anyway, there's that. Oh, and then a whole bunch of Desmos applications that I wrote for other classes. If you're interested in developing in Desmos, especially developing this suite of Desmos apps, here's a bunch of links from Desmos that will help you do that, and a bunch of future work, especially this one here. If you use any of this stuff, please send me suggestions. I'll probably entertain myself in retirement by maintaining this until somebody wants to take it over. All right, so the only thing we didn't get time to do is show you some of these nifty Desmos stuff from other classes, but we can let you look through that. So I think I'm done presenting. What do you think? Any questions? Oh, thank you, Venki. Venki, I remember early on that you were impressed with the Desmos Dataview, and that kind of spurred me to go on and work on it even more. I actually got this. I started doing this because of one of our high school teachers turned me on to some of the functions in Desmos that do statistics. Really? Nobody has any questions? Okay.
TJ,
Yes.
when you teach statistics, is Desmos now the only technology tool you use in your class?
Since I went online and used the MyLab stuff, I've been having them use StatCrunch before they use any of this.
Got it.
Yeah. And if I was going to keep at it, I would make up some assignments that would use something a little fancier than StatCrunch, although I never got a chance to figure out what to use. Do you use like Studio R or RStudio or Octave or anything else? What's VT using these days for intro stats? Virginia Tech.
I don't know the answer to that. I use Excel in 155, but I'm not teaching the Math 245.
Yeah. You know, that's a whole big issue we just started talking about at Blue Ridge. If you look at the descriptions from the pathways work that we did, the descriptions between 155 and 245 are not that different. And I think that so far we've just been teaching 245. I'm going to recommend to my group of statistics instructors here at Blue Ridge, with your permission, could we get in touch with you and get your views on how to teach 155? Because we're just not clear on what level to pitch it at. Does that make sense?
Sure. Yeah, I don't know how helpful I'll be, but I'll try.
TJ, this is Cheryl Brundle. I'm at Lord Fairfax.
Yeah.
And I was actually on both the 155 and the 245 pathways, VCCS committees to rewrite those. And we did a very purposefully match the 155 up so it mirrored the 245, but just at a intro level. So that was very purposeful to get those together, to get to do those. And I just wanted to let you know that I use StatCrunch for both of those. We use Excel in the 154 class, but I use StatCrunch in the 155 and the 245. And actually, I used Pearson products, so I've been using my StatLab also with the 245. My 155 students absolutely hated my StatLab They love StatCrunch, but they had a very hard time. And the reason is because the technical way that Pearson has them answering a lot of the, write the conclusion for this hypothesis test, and the wording was higher tech than what we were teaching in the 155. I didn't dumb it down. I gave them sort of templates as to use this to write your conclusion. And it never really matched up with what Pearson was doing in my stat lab. So I got rid of my stat lab and I just give them written homework and StatCrunch assignments, and they really liked StatCrunch.
Yes, I also really like StatCrunch. I thought they did a very good job with that package.
Yeah.
I've never done the stat, what is it, my stat lab?
My stat lab, yeah. If you've done anything with Pearson, it's just like my math lab, but it's just based on the statistics book.
I do.
And then it has StatCrunch included in it.
Were you using Triola?
Yes, I am.
Well, that's why the wording of the conclusions was, although Triola says is in non-technical terms, he's lying.
Yeah, that's true.
Very confusing, overly technical terms, actually.
Right. I love the Triola books, but I do redo there are a couple things that I don't agree with him, but he's sort of more of an expert than I am. But I do redo the conclusions and I give them, here's what they say, but this is how I would rewrite this in more layman's terms.
Do the same thing. Yep. Yep. So I'm so glad that you spoke up because of this difference between 155 and 245. Tell me if my impression is correct. You're really covering all the same material in 155 as you do in 245, but you're just going to allow yourself in 155 to teach it more conceptually with less calculations. Is that the idea?
Basically, we don't do everything in 155. It's like we do a little bit on confidence intervals, but not as much as you do in 245. We do, t-tests and z-tests and one props, and we don't do anything. Well, I don't do anything with two sample data, but I spend a lot more time on linear regression because usefulness, linear regression is probably more useful than any of the other ones. And the project that I have them do is for the 155 is that they do a linear regression project. Nice. My 245 students get to pick, they get to go out and get their own data and they pick whatever test that is appropriate for their data set. Yeah. But I key in on the 155 students, they do linear regression because I think of all of the tests, they can understand that better, in real life, how that's, very useful in real life. And so that's what I emphasize. But we do, we go through chi-square in 155 and because it's in the course content summary, but I also do that in my 245 class, yes, which is not in course content summary for 245. It's technically in 246. But I love chi-square because I want to do the M&M simulation every semester. Oh yeah. So I bring in chi-square into my 245 also.
Plus chi-square is so usable and understandable.
Yes, and I really wish we had an extra week because I really like to do ANOVA testing also, but there's just absolutely no time.
Yeah. So when you say that you have your 155 students do a hypothesis test, it seemed to me that in order to take a student through the process of doing a hypothesis test, they'd have to do all the same stuff that a 245 student would have to do. Isn't that true?
They do, but we don't do as many. Like I said, I'm not doing two samples hypothesis tests, so that takes out half of them. And we basically I do t-test, z-test, one prop z, chi-square for just contingency tables, and then linear regression. So that's like half of the hypothesis test. And I expect them to do all the, I go through, I don't check requirements. I don't do all the, detailed stuff that we do in 245. Yeah. But, we talk about sampling and I talk about, having to have a simple RAM sample, and we talk all about that. But I don't, we're not doing requirements and all that type of stuff in the 155s. So.
Super. Okay. Thank you so much. Yeah. I'm so glad you spoke up about that.
Yeah. But if you, I was gonna say I could send you my syllabus, but that's not going to do any good. It doesn't give you specific instructions.
I
But
could,
we use,
I could invite you to our faculty meeting if you want.
you could, I'm trying to think, the book that we use is a Bennett with, and Triola was an advisor on the book, and I can't remember the name of it. And I think it's called Statistical Reasoning.
Okay, yeah.
So it has a Triola flavor to it.
Mhm.
So, and a lot of it, I borrow stuff from my 245 and put it into the PowerPoints and stuff.
Well, let me put you on the spot. Sure. Oh, there it is.
Yep, that book,
That might be the, yeah, statistical reasoning for everyday life.
that's it.
And I really like this book.
Yeah.
Can I put you on the spot now about this Desmos stuff that I just presented?
Yeah.
Can you see any way you might be able to find it useful in what you're doing already?
What I loved about it was that you could superimpose all the graphs on top of each other. When you did the histogram with the dot plot in the back and the
Yeah.
box plot, and that was like, whoa, that would be worth it, because in StatCrunch, you show one graph at a time.
Yes.
But when you did all of that, that's the most impressive thing I have seen in a long time, because almost everything else you can do in StatCrunch.
You can actually do the stuff. You're absolutely right. You can
Yeah,
do
but
all those
that,
computations in StatCrunch.
that one, and even StatCrunch has all the simulations too.
Okay. Oh, you mean I show the graph? Yeah.
Yes, but that one thing, that right there that you have on the screen is the most impressive thing that I have seen in a long time.
Oh, lovely.
So, and so you said you wrote that, you built that?
Yeah.
Perfect. So, yeah, I already downloaded your file onto my desktop. It's like, I am gonna, that was just, whoa, because it makes sense. Because I always make a big deal that when we talk about histograms, you lose the data points. You don't know what's in the histogram, but superimposing the dot plot on top of that was just like, all of a sudden, to me, it made the histogram make more sense. And because we talk about, where you have 5 in the category between 12 and 15, but you don't know what they are.
Yeah, right.
So that was, I love that.
And if you look at the screen, you can click on each one.
Yeah. So you should contact StatCrunch people, and I forget what that guy's name is, and say, hey, I will help you write this program and see if they can hire you on to get that into StatCrunch. That would be so wonderful.
All right. I'll look into that in my spare time.
Well, you said you were retiring.
Yeah, but I'll be busy.
That's true. But if you get in touch with your Pearson rep, the guy who created StatCrunch still works for Pearson.
Really?
And I can't remember, I used to have emails that I would write to him back and forth and go, hey, can StatCrunch do this? Or can you think about doing this type thing? And for a while, I was getting replies from him. I don't think I am I haven't written to him for ages and ages and ages.
Well, I wouldn't mind contacting him. I would call him right away.
But there are a couple things, like I really wish they would do back-to-back stem plots. And a couple other things that they don't.
Sure.
And just little things like that was like, this would be really kind of fun, but.
There's 2 things I can think of right away that I liked about StatCrunch, little things. One was when you made a histogram, they allowed you to put the height of the bars written above the bar.
Yes.
I love that. That makes a histogram really work for me. The other thing was the calculator for the normal probabilities. Within one calculator, you could both calculate probabilities and do the inverse norm.
Right. Yeah, I like that.
With their clever little GUI they had there. Yeah.
The other thing I like about StatCrunch is that you can relabel the x-axis on a histogram, because I make a big deal about using midpoints. And there's a way that you can relabel it and have the midpoints come up on the x-axis for the histogram. So just little things. And some of it's really funny because I'll have students come to me and go, hey, I found something that we aren't doing in StatCrunch. Look, I found this. It's like, because they change it all the time.
Oh yeah.
They keep updating it, and I don't keep up with all the updates.
Sure.
But Yeah, because I think one of my students figured out how to put the midpoints on it for me. And I didn't know how to do that.
Well, Cheryl, thank you so much.
Thanks for letting me talk.
Oh, thank you. Grant, are we good?
Yeah, we are good. It looks like we're out of time. Thank you so much, TJ, for sharing your knowledge and insight with us. I posted the link to our virtual booth in the chat. You can be entered to win your choice of an Apple Pencil, Amazon Fire Stick, or $100 Amazon gift card. And that booth will be open for another 30 minutes. I hope everyone has a great weekend, and thank you all for coming.
Thanks, everybody.
Thanks, TJ.
Thanks, Jason. Good to see you.